Okay, now we're going to look at section 7.2, compound interest. So it's really important that you read your book on this one. I have now, as you would have seen, made reading that an assignment and commenting, just so that it makes more sense when you're doing the problems. These are really based on a lot of the concept things. And if you have questions, let me know. So compound interest, so I'm going to pull up the book just really quickly. And this one is just going over. I don't want you to submit this example. It's in your book. But the first month, if you put in $1,000 and you get 3% is the annual rate, and you're dividing that to get the per month rate because it's done monthly, you would have 0.25%, which then converts to 0.0025. So be careful of that. It's really tiny percentage a lot of times on these monthly rates, or if you're looking at it daily. So I'm going to push this up. Then what happens is this would be the interest earned just for that month, but then now that goes on to your principal. It gets added in to your principal, and now this new value, $1,000 and $2,002.50. So we're going to then look at this chart here, how it builds. And so every month you're getting more and more interest earned. It's not the same value each time as it was with simple interest. So here we have compound interest, and it's more of a curve. It is a curve. And I'll show you what that looks like. That's on page 255. So here's where it would be if it were just simple, but then compound, it's a much bigger bang for your buck. So now we'll do an example. And now we're going to start the notes that you're going to turn in, whether I do them on the video or you do them for classwork. See page 253 in textbook. That's the chart that I just showed you. It's when we're putting interest in on our interest. I'm not going to derive this formula. We'll just take it at face value here. If you were doing like a algebra 2 or pre-calc or something like that, you might get more into that. So here we have some new letters here. P sub n. N is the number of years, so P sub n is the value in the account after n years. It's kind of like the capital A end amount, but we're just using this P with a subscript. That's our same initial principal. And then we have R, which is our annual rate, but divided by the number of compounding periods in 1 year, times the number of years, times K, the number of compounding periods in 1 year. So for example, if we have annually, that's 1 time a year, quarterly, K would be 4, monthly 12, daily we're going to use 365. You also want to take a look at the rounding error that can happen with these type of problems. For example, in your book on page 257, if we rounded within a problem, we're going to get some rounding error. So if we shorten it up here, we get $4,208.59. If we don't round, look what happens. We get a lot more. So we do need to watch for that. So we want to keep everything in our calculator. I'll model that as we go. And here's a nice thing, little chart with directions and stuff. A lot of you probably don't have a Y to the X key. You probably have something that looks more like this. A little caret. Okay, be careful you're not always using like a squared button, because the exponent is going to vary each time. You also need to make sure that you're using parentheses carefully. So when you're doing your paper quiz or your homework, stuff like that, and you want me to check your steps, give me some in between, and you'll see how I write it out. If I'm not rounding, I put like a little dot, 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 just to jot down like, oh, I have that in my calculator before I go to the next step. So again, I'm probably writing a little more than you would need to for a quiz, but you should keep in mind, show me more steps for partial credit is better than not. Okay, so now we have this example 7.4. Uncle Moneybags gives nephew starving actor $2,000 to deposit in a savings account earning 3% interest compounded monthly. Okay, so this is annual interest, not monthly. It's not done out for us, so we do have to divide that out. So R would be 0.03. Monthly, K is going to be 12 for this problem. P sub 0 is what is being deposited, so that's the 2,000. And the question asks, how much will nephew starving actor have in the account in 20 years? So our time N is 20 for this problem. And we also need to note that we're trying to solve for how much we will have, and that's going to be our P sub N. So it's important to know what you're given, what you're trying to find, map that all out, label up your problem, and then also think about what kind of problem it is. We do want to make sure we're using the correct formula. So this is, he's making a deposit and it's compounded monthly. So there's something, the bank is having an action. We put in one lump sum, or nephew did, and then it's just sitting there, but the bank is compounding it. Later we'll see with annuities that you're putting in money every period, not just one time. So this is one lump sum. So I'm just going to put the formula that we need to use. I'll just stick it down here so that it's handy, just so you can match up. So we're going to just go ahead and plug everything in. We're going to have our $2,000 there. We need to have our 1 plus our R over K, which is 12 in this case. And then it's going to be NK, so 20 times 12. So now that everything's plugged in, I'm going to walk you through how I would do this with parentheses. And you can match up and see how you do with that. So we first need to do this whole big bunch of stuff. You can calculate this out ahead of time if you want to be 240. It does terminate, so that's not going to be too much of a problem. But the things that, some things might be harder than others to deal with. So we're going to have, I usually start right here, 0.03, 0.03 divided by 12, and then I hit the equals, and I get 0.025. So, put the lights up a little there. I leave that there, and then I add the 1, and I can go backwards like that because it's addition. So it's going to take my previous answer and add 1. Don't forget to do that. You'll get a weird answer if you don't. So you get 1.0025. Then I'm going to raise that up. So I'm going to use this key right here. This is my raising it up. So it's going to take that answer and raise it up to the parentheses, 20 times 12, or you can just do that out in your head, but just want to show you how to use the parentheses, and then hit enter. So now at this point, you should have 1.82075, so on and so forth. Okay. Now we're going to take that number and multiply it by 2,000. And you should get $3,641.51. cents. So we do want to write our answer in a sentence. So he will have $3,641.51 in the account after 20 years. So how much interest will he have earned? So that's what he's going to take back out of the account. So we need to just take that value and subtract off what we put into the account. So it's not just a simple interest where you're doing principal times rate times time. This is a total cumulative interest problem where we had compounding involved. So this formula is p sub n minus p sub 0. So go ahead and do that. You can pause the video and just do it and check your answer. Okay, so you would just write it like this: $1,600.51 was earned in interest over the 20 years. You can just be pretty brief with it. Okay, for this problem, we're going to look at page 78, example 7.5. Suppose Professor Smart wants to save $20,000 for his newborn son's child genius college education. If the account earns 5% annual interest and he anticipates his son will attend college at age 16 years, how much should Professor Smart deposit today? So we are having it just compounded. It doesn't say that it's monthly or daily, but it is earning that interest every year. So that means it's compounded. So we are going to use this formula right here. It's a little bit different though because we're given that what he wants to have, so we're given p sub n, and we know that r is 0.05. It's annual interest, so we are going to have k equal to 1. It's 16 years later, so n equals 16. And I think that's all the things that we need. We are trying to find p sub 0. That's our question mark. So we're going to go ahead and just fill in. I'm going to have you stop the video, fill in all the pieces, and try to crunch the numbers. If you get stuck at the bottom, try not to round it all, and then I'll show you on the calculator how it all works out. I do want to point out this one is a little bit sketchy, whether it's simple or compound. It's not that clear. On your quizzes, I'm really clear that it's would be, I'd say, compounded annually, just to be clear. Okay, so hopefully you were able to plug in these values and get the 20,000 in there and the rest of it, the R and the N. We really didn't need to put the K in because it's 1, but just for emphasis, I want to show you. And so how I would write that out on my calculator, I would do 1.05 raised to the 16, and I get 2.18, and so on and so forth. So I just leave that in my calculator, but if I were taking a quiz and I wanted my teacher to know, just in case I made a mistake hitting a wrong button, that I was working at it and just didn't have some random number there. So you can write this, but put ... meaning it does go on, but I'm just jotting down the in-between step. Then I would want to divide both sides by that number, right? Using our algebra. So you could, maybe show me that. And then what I want to do here, though, is just leave that in my calculator. I'm going to punch in 20,000. And then divided by second, and then this answer key right here, and then enter. So this is what it should look like on your calculator. So we're going to get, he should invest about, because again, we are kind of rounding, $9,162.23 in that account. Okay, so one of the notes down here does say, I'll push this way up. When using the calculator to round your answers, be sure to round correctly to the nearest cent, since the result is in dollars. For example, if you have this for an answer, we're just going to round off, okay? So sometimes you might need to interpret it like I need to go a little bit higher to have enough and things like that.